And now I would like to welcome our amazing speaker, Ovia Seshadri. Ovia is a respected research engineer at Coindcx, specializing in proof of work blockchains with a PhD in computer science and engineering from IIT Delhi. As the Chennai chapter lead of the Phoenix Guild, Ovia is dedicated to fostering the growth of the blockchain community with, with extensive expertise and a passion for innovation. Ovia contributes to shaping the future of blockchain technology. And today we also have a special guest with us. I would like to welcome Venkatesh. Venkatesh is a blockchain engineer who loves exploring the new technologies and is now fully committed to make a mark in the industry. He has experience of working with companies like Nethermind and is now on a mission to establish his own startup by next year. Welcome, Venkatesh, and welcome, Ovia.
Thank you, Bhavya.
Yeah.
Awesome. Welcome back, everyone. I just want to know how many of you are joining for the first time, and how many of you have been with us throughout the past 3 sessions. You can put a note in the chat box. Apologies for starting a little bit late. Today we've changed the format a little bit from a seminar to a meeting so that it can be more interactive. So I had to register for the session and join. So it took a little time. So I think Bhavya, Venkatesh is not able to speak because
yeah, now I can. Yeah.
Okay. Hi, Venkatesh.
Yeah, hi.
Okay. So Venkatesh is a colleague of mine at the Phoenix Guild. He also heads the Hyderabad chapter. So it's lovely to have have Venkatesh here, who's an experienced Solidity developer. So you're all very privileged to hear from him today. Before we start, we'd like to I want to recap a little bit, but the best way to recap is through a quiz, I think. Bhavya, do you want to do that now?
Yeah, sure. So everyone, you can just log into kahoot.it and we'll be sharing the Kahoot quiz on the screen. And yes, you can actively participate in that. And we do have some amazing prizes for the winner today.
Awesome. Do you want to put the link of Kahoot on the chat box so people can
Yes, I'm just bringing that up.
Yeah. Or you could also just scan a QR code if you're going to join, if you're playing from your phone.
Yeah. Okay, my screen isn't visible.
So all the code from the previous sessions must have been shared with you through on the Slack channel. So I hope you guys had time to look at that. Even otherwise, the videos are already up, I guess, on YouTube. So that would have also been a good place to revise. I hope you guys enjoy this quiz. It's a fun way to just recap, revise everything we've seen so far in Solidity. Okay, I can see about 10 participants other than Venkatesh, Bhavya, and I. So
Are some of you still joining in? Okay, I think we'll take another minute and then we'll start. All right, Ovia, should we start?
Yeah, let's start.
Okay.
The first question is coming up. So you just guys have to just take the correct color, okay? Based on what you think the answer is. Question is, which of the following options define the solidity function with one input parameter and a return value? So whichever color you think is the right answer, click on that. We have 8 participants. I think you can still join the game.
Yeah.
Two of them have answered. Okay. Bhavya, I think there's a time limit, right? So was the time limit sufficient for you guys?
We could edit the time as well if you think you need more time to answer.
I think it's about 10 seconds. Maybe we could keep it to 20.
It is at 20 right now.
Okay. Okay, let's go on. If you have
All right.
some difficulties, just put it in the chat box. Awesome. So the correct answer is yellow.
All right. Next question coming.
Question.
Okay, so we have the leaderboard.
Awesome. Which of the following options correctly declares a fixed size array of type string with a length of 5?
So we have to.
Nicola and Mackay think it was a little fast, so maybe we can increase the time.
We'll have to start it again. Like we suggest like this time because we don't want you to Google it. If you know it, honestly, I think it'll be fine.
Okay, let's just go with it. But I think since there's a price at stake, the competitive sides are coming out.
Arvind is leading the leaderboard.
Okay. Which of the following statement is true about the revert function? We saw this last week. Awesome. Most of you got this right.
Oh, Arvind is on a streak.
Arvind is on a roll, yes. Three, two, one.
Oh, most of them answered that correctly.
Nice, I'm happy.
Yeah, amazing, folks. Keep that up.
Awesome.
3 more questions to go.
Yep. The questions are relatively simple. And we only stuck to theory questions. Yeah.
Amazing. Let's see if there's some movement in the leaderboard.
Amazing. A 50% chance in this question.
Yeah.
Nice.
All of them got it correct.
Very good. Great.
The last question for the day. Okay, so I see most of them got it right.
Do we have one more question?
Yes, we have one more.
Last question.
Okay, now everyone is picking speed. Wait. Let's see the leaderboard.
Amazing. Third position, we have M. And then second, we have Avani. And on top, we have the winner, Arvind. Congratulations.
Amazing.
Awesome. So you should watch out in the Slack channel. Bhavya will
Yes.
update you on the reclaim your prize.
You'll be heading out from a zone.
Okay, so let's get started. So today's session is going to be a little bit different. So I had a few topics that I couldn't cover last class. So I'll just quickly take 10-15 minutes to do that. And then I'll be passing over the mic to my colleague Venkatesh, who's going to be taking you through a small smart contract development project. And I'll let him tell you more about that. I'll also introduce, tell you a little bit about the tool that Venkatesh is going to be using, which is Hardhat. We've been seeing contracts developed in Remix till now, but he's going to be using Hardhat, which is not too different. So let's get started. Okay. Yeah, let me first share my screen. Yep, I hope you can see my screen.
Yes,
Yeah?
we can.
Awesome. Okay, so last class, we covered quite a bit. We started with what primitives are, the two data types, value type and reference type. We saw some examples of all of them, small contracts that use different types. We saw the two types of address data type, which is address and address table. We saw what arrays are, strings, structs, example of mapping. And then we saw a few gas optimization techniques, they're not very too advanced, just simple things related to data types that you can remember to optimize gas. We saw conditional statements, if else loops, specifically for and while loops. We saw what a function selector is, and we saw how it is used in the block explorer. What function modifiers are, what are events, what are errors, the types of different types of errors that we have in Solidity. We saw the three types of storage called data, storage, and memory. We saw each of them in example as well. And then we saw two functions which are called fallback and receive for when call data or value is passed to a contract in transaction, in some kind of function invocation transaction, and there is no proper function to receive it. That is, function selector is wrong. So what do you do in that case? It will just automatically send to a fallback function, which will get executed. Or if there's a value, receive is a special case of fallback function where a value is passed, and the receive function will have the logic on what to do with the ethers that has been sent. So this is what we did last week. So this week, I'm just going to take a few minutes to talk about a couple of things. Inheritance also we saw last week, but I just want to recap it again. Inheritance is very similar to any other object-oriented programming. Like if you're familiar with Java or C++, where you have classes and then you can instantiate the class with objects, and classes can inherit. One class can be inherited from another class. It's very similar. Here, classes are just the abstraction that we call class is here. It is a contract. So each contract have state variables and methods that can be inherited onto another contract. So let me just. Right. So we have. So let me just. Yeah, so I hope you can all see my screen. This is the example of the inheritance contract, where a contract contract B inherits from contract A, contract C also inherits from contract A. Contract F inherits from B, and contract D and E inherits from both from B and C. So in other object-oriented programming, you wouldn't have seen this kind of thing, multiple inheritance, but Solidity supports multiple inheritance. Last week we had a question also, how does it solve the diamond problem? So a diamond problem in other object-oriented languages is when a class, if it inherits from multiple parents, and the parents have the same function, which function would the child class basically invoke? This is solved in Solidity by, it has a rule that the override happens from right to left. So the function that is on the right side will get invoked. For example, so contract D inherits from contract B and C. Inheritance happens through the is keyword, and the function foo, which is present in both contract B and contract C, has to be overridden. So if function definition is not present, automatically the parent invocation is taken. If the parents have it, it follows the right to left. So here the function definition is present in the child contract D, and it basically returns the parent. Super basically calls the immediate parent. So the immediate parent foo function is invoked, and it would return C because that is the rightmost inherited parent. So this is what we saw last week. I just wanted to quickly recap. Okay, so now today we move on to. Okay, so today I want to talk about interfaces. Interfaces is also very similar to other programming languages that we've seen before. So interface provides an abstracted layer where you know exactly what is present in the contract. You can see all the functions that are present. You can see the function signatures without knowing the actual implementation of the function. So it is a way to define a contract's external facing functions and events without actually implementing their full functionality. So if you want to write an interface for a contract, you should specify all the external function signatures and its return types, but you don't have to write the actual code. This is important because there are several advantages. One of the advantages is the interoperability and standardization it provides. So if you have large projects where you have very complex contracts and or if the contract code, if you wish for it to remain secret, then you can just write the interface. You can expose the interface where other contracts can interact with your contract through the interface without actually knowing your contract's code. So best way to learn is through examples. So let me show you an example. So we have the interface contract here. So there is a contract called counter, which has a public count variable and an increment variable, which is also external. So anything public and external can be used can be given in the interface. As you can see, even the state variables are provided as a getter in the interface. So you have an interface for this counter contract called iCounter, and this myCounter wants to invoke functions from the counter contract, but it need not know the actual contract code. It just needs to know the interface, how the function, the signatures of the functions in the contract counter. So in this myCounter contract, you have a function called increment counter, where the address of the iCounter contract is provided. So how you can understand this is, this contract is deployed and an address is created for this contract. This myCounter contract, when it is deployed, it knows of this interface. So it just knows how to call these functions. At runtime, the address of this counter contract is assigned to the interface object, interface instance of this myCounter. So when you invoke increment counter, you would pass the address of the counter contract, the first contract, this contract, and automatically it is assigned. It knows that the contract address that is passed here, it will have the function signatures of the iCounter object. So let us see this in example. Okay, so this is already a compiled contract. So let us deploy it. So I am deploying. You can deploy this counter contract separately, but you would need the interface object in the same file when you're deploying the myCounter contract. So let me deploy this counter interface. Yeah, so I'm deploying this because I need the address of this to invoke functions here. So I'm deploying it first. So in actual implementations, you just need the address of this. You don't need the actual code of this. So now let me copy the address of the counter contract that we just deployed. Now I'll deploy my contract, this contract. I've deployed that. So in my contract, if I have with this some function, 1 second. Okay, my apologies. I should have renamed this. Let me just comment this out. It has taken this my contract instead. So let me just comment this out for now. I wanted to show you another example, but it is okay. Let's delete these two. Yep. So counter deploy, copy this, my counter deploy. Yeah. So now if you see, my counter has two functions, increment counter and get count. So now both these functions take an address of underscore counter, and we know that the underscore counter is actually of the type iCounter. So at runtime, it is assigning the address to iCounter. So if I say increment counter and I pass in the address of the counter here and increment counter, automatically the counter has been incremented. So if I get count over here, like pass the same address and get count, the count has been incremented to 1, even though this doesn't have a counter object, right? The plus count plus 1 is actually there here, but the code to increment is actually there in the counter contract, but we were able to do the increment function through my counter. A real-time example, I hope everybody understood this. Please drop in the comments if you have any doubts. Let me delete these now. So I'll also comment this out. a very practical example of interface, a place where interfaces is used very often, is the Uniswap. So Uniswap is a DApp for swapping tokens. We haven't looked at tokens so far in this bootcamp, but we will be covering ERC standards in the next class, where all of this will make much more sense. But what I want to say here is this Uniswap example, it needs to deal with two tokens, and it has a function to get the amount of these tokens in the pool contract. But so here, even though it's using some other contracts that it doesn't know of, just by having the address and the interface of how those contracts are defined, the functions, how those functions look, the signature of those functions, it is able to write logic on how what it wants to do without actually knowing what this get pair function does or get reserves function does. It just needs to know how the function's signature looks like. So this is a very nice example of understanding interfaces. You don't need to know the exact logic to invoke the function. You can just assign the actual contract you want the interface to represent at runtime. So an interface can also be implemented, that is inherited. So this was the example I had to show you how interfaces can be inherited. So again, you have an interface with some function definitions, function signatures, not definitions, and you can also have events. So every public external functions can be not private, everything except internal also. Internal functions can be inherited. So all of that can be represented in an interface. And a contract can implement this interface by using the is keyword. But if you want to invoke the function of the interface, you need to pass the address of the contract that actually has the definition of it. So that's all about interfaces. Okay, we saw the concept of shadowing in the last class, where I said shadowing, you don't have to worry about it because most IDEs these days will not allow shadowing. Shadowing is the concept where you use the same name, variable name, or the function name with the same signature, where the same function is already present globally. If a global variable and a local variable have the same function name and function of variable name and the signature, then that is called shadowing. The preference is given to the most recent one, that is the local one, but most IDEs don't allow you to do this. A good practice of differentiating the local variable and a global variable or a variable that is passed is by using the underscore. You use the underscore to refer to the local variable. So yeah, this will throw an error directly if you use it in Remix. We saw how that is prevented in. Let me just see if I can get that code again. Yeah, so basically, so here we have a contract B that that inherits from contract A. Contract A has a string public name. Now, if you have a string public name again in contract B, it will directly throw an error, so it is not allowed. So if you see that, Remix already throws an error because the identifier is already declared. So you don't have to worry about it, but this is just a concept and a name that you should be aware of. So now going to the next. So a little bit, there are two slightly advanced, not advanced, intermediary concepts that that will kind of put a nice end to learning Solidity. One is how to call other contracts from a contract, And the second one is how to create a contract from a contract. So let's see how to call a contract from a contract. We'll call the contract that is calling another contract the caller, and the contract that is getting called the callee. So we have the caller contract calling the callee contract. So there are two ways in which you can call. You can, in the caller contract, you can pass the address of the callee contract in one of as an argument, as a function argument, or in one of the functions, you can define the callee type and assign the address of the callee contract at runtime. Let me explain how we can do these two things. So let's go to, yeah. Right. Right. So we have the callee and the caller. So one thing to remember is we need to know, so we are defining the callee type in the caller because the caller is calling the callee. So the caller needs to know of the callee contract. So when deploying the caller, you should at least import the callee contract. If not directly put the contract, like as I have done in the same file, I've put the callee and caller contract. So when you deploy the caller will already know the exact function signatures of the callee contract. Right? You can also use interfaces. We'll see that a little bit later. So what I'm trying to say is you instead of putting them as two separate files, you can import it in the caller contract while deploying the caller contract, or you can directly put the code like this. But you would have to deploy the callee separately also. The callee doesn't need to know about the caller, but the caller definitely needs to know about the callee. So I mentioned two ways in which you can call the callee from the caller. Is the words getting a bit confusing for anybody? Please let me know. And Bhavya, please let me know if there's any comments in the chat box. Okay. So the first way is by passing the address of the callee directly. So we have the callee contract, and the callee contract has a variable X that we want to set, right, through the caller contract. So in the caller contract, we have a setX function. Now, the two ways I mentioned is when directly passing the callee address in this as an argument. And the second way is to declare some a variable of the callee type and then setting its address at runtime. So these are the two ways in which you can do it. The first, here what is happening is the call, you're taking an argument of the type callee, which is basically the address of the callee. After deploying the callee contract, take the address and pass it as an argument when you're calling this function setX. Okay, and automatically, this function, this underscore callee is basically a reference to the callee contract, and you're invoking the setX function of the callee contract with the value that you're passing over here. So let us see how that works. So I'm going to first deploy the callee contract. Remember, the callee doesn't need to know about the caller. So I'm going to just deploy that. So I have the callee contract. Now I'll deploy the caller contract. The caller contract needs to know the function signatures of the callee, right? So now I have the call. I'll just copy the address of the callee. In the caller contract, I want to call the setX function, which will basically set X of the other contract. So now if I pass the address of the callee, paste, and then let's say I want to call the function, I want to set the value of X to 3. Before that, let's just quickly check what the value of X is. It is currently 0. Can you see here? I hope you can see that. So now if I invoke the setX function by passing the address of the callee, the transaction has succeeded. Now, if I go back and check the value of the X value at the callee again, you can see that it has been changed to 3. So by this way, we are able to change the state variables of the callee from the caller contract by just passing the address, right? Another way is to use the second function from the address. So here I'm not taking the type callee, I'm just taking a random address, and then I have created a variable called callee, and I'm assigning it to this address at after calling at runtime. So here, so now we know that the variable x is 3 now. So here again, I'll copy the address of the callee again, and then I'll pass it here and say I want to set the variable to say 6. Okay, so it was 3 before, now I'm setting it to 6. And from the caller contract, I'm calling set x from address. So the transaction has gone through. So now let's go back to the callee contract and check the variable x. And you can see that it has been changed to 6. So these are the two ways in which when you have two contracts, the caller and callee, you're able to manipulate the state variables on the callee contract from the caller contract. Okay, so now what if we don't have the callee contract, right? I told you that the caller contract needs to know the function signatures of the callee contract, but only the function signature. It doesn't need to know what exactly happens in the setx function to call it. Only the function signature is enough, because in both functions of our caller contract, we're just invoking the setx function of this callee. We don't need to know what exactly how this function is exactly written. So it is enough for us to just have an interface. So this is the second example. Let's say that you have an interface of the callee. You don't have the exact callee function, but I'm just written the callee function here, which implements this interface, right? So now it's important that I wrote it here because we need the address at the runtime. So that's why this is here. So now I have a caller contract also, which basically does the same thing, which is what it set x, and it takes the argument two ways. It directly takes the callee address as the argument. And the second is it just takes an address and sets it to the interface at runtime. 1 second. Not able to scroll properly. Okay. Yeah. Okay. So it takes the address as the parameter, and it has a type of the interface callee, and it sets the address at runtime. So let us see how this works. I'm going to delete all of this. Right. So first I will I have the callee 1. I'm going to deploy that because I need the address of it, but the caller does not need to know anything about this callee 1 contract. So I have the callee 1. I'll copy that address and I'll deploy the caller 1. So now the caller 1 is completely written by only knowing the interface of the callee. It doesn't know the actual callee. So if I invoke again, this callee 1 has x value 0 in the beginning. So now through caller 1, I'm going to set the x value. So I'm going to call the function set x, by passing the address of the callee function, but it is mapped to the interface of the callee, not the actual callee. Pass the address, comma, let's again set the value to 3. The function is successful. The transaction has gone through. So in the caller, we have the value has been set to 3. In the other method, which is this one, set x from address. This one. So let's paste the value of the address again. Let's change it from 3 to 6. Set x from address. Again, it has gone through, and we'll check the value of x that is being changed to 6. So this is how you call a contract from another contract. We saw how to call a contract via interface and how to call the contract directly. And we also saw two ways of calling the contract, one by passing the address directly as an argument, and also if you know the signatures, you can create a variable of the type the contract and assign the address at runtime. Right? So that's how you call a contract from another contract. So now moving on. So how to create, this will be the last part of Solidity that we look at. We'll do a project right after this. And next session, we will go through some of the standards in Ethereum, and tokens. So this is how you call a contract, how a contract can create another contract. So the standard notation of when a contract creates several other contracts, we call it a factory. This is a very common design pattern that is used in many other languages, and it's the general term used in software engineering. When a class creates many other classes, you call it a factory. Here, a contract creates many other contracts, you call that a factory. So the factory is also a contract that basically has a function that is responsible for creating other contracts. And the factory will maintain like an inventory of all the contracts that is created, the contract addresses, and some of the important information of that contract, like important state variables, things like that. So, so you have one contract called the factory, and whenever the create function of that factory is invoked, it will create a new contract. So the how this contract should be designed is already there. You already have like a template, you have the code ready. You just assign the exact values and a new address, account address at runtime. So let's see how that works. Contract from another contract. So here we have a general template for a car. A car has an owner, a model, and the address, right? And we have a constructor for the car. So one thing to remember is whenever you have a template for a contract that is being created from a factory, a constructor is very important because the constructor is used to create it. So you always define a constructor. So the constructor basically sets all the state variables for this contract, right? So this is the template of a car that the factory contract will use. So yeah, so this is the car factory. It has an array of all the car it is going to create. So when deploying the car factory, this array will be empty. And for every car it creates, a new address is created and one entry is made in the array. So this is important for us to have to loop through all the contracts, or just to have accountability. Because if you directly deploy a contract from a contract, you won't, I mean, there should be a way to get that address and store it somewhere so that you can refer to it at a later point in time. So in this car factory, you have a function called create that basically takes the owner and the model, and it creates a type car and a new object, car object. It's not an object, it's a new contract basically. So here the constructor function of this car is invoked. Because the keyword new is there, a new address is generated, and it is assigned to this variable car. And the end, the new car is pushed to the cars array. And the cars array is of the type car also. So when you're deploying the car factory, it's important that the car factory knows the template of the car. So this code is also important. So this car factory can either have an import statement of the car.sol or just have the exact code of car written over here. So this is how you would do it. So let's see. So let's deploy it. Just going to delete all of that. Okay, there is a small error in this code. Okay. So, oh, sorry. So you don't have to deploy a car, obviously. The car factory is going to create it. So I'm just going to deploy the car factory. So in the car factory, I'm going to create a car, right? So let's do a create. In create, I have to pass the address, owner address. So I want to create a car for myself. So I'm going to copy my address, which is the owner, and the model. Let's say I'm going to get myself a Tesla. So this is the create. Automatically, the transaction has gone through, and a value has been added to the cars array. So if you can see, the transaction is successful. Let's try to get the car. So I want to get the car at position 0, right? So now if you see that position 0, address is 5B3, which is my address. You can see 5B3, that's my address. And a model is the Tesla, and the car address is this address. So this means this is the address of the contract that represents this car. Okay, so let's try to do this in MetaMask so we can clearly see how this contract also looks. So I'm going to delete all of this and go to injected provider MetaMask. Oh God. Okay, I have forgotten my MetaMask password. Okay, I think you should try this on your own because I don't know my MetaMask password. I'll have to install it again. That might take time. So maybe after Venkatesh's session, I can show you this. So what we would be doing is basically creating cars. That is, this car factory will be creating our car contracts, and we can see the car contract with its addresses directly on Blockchain Explorer because a new contract would have been created. So this is all I wanted to say to talk to you about today. One more thing. So this create, another way to create is to do create to, where you add a little bit of salt. So we haven't seen this salt before. Salt is just a value that you send in the call data to kind of ensure some kind of uniqueness. So this basically, this will allow you, by tweaking this salt parameter, you can predict the address of the contract that you're going to deploy, or you can control it to an extent. So this is a little bit of an advanced concept, but I just want to know that something, I want you to know that something like this exists. So yeah, maybe after I'll just install my MetaMask, and meanwhile, let's over to Venkatesh. Venkatesh, are you ready to take it forward?
Yes, Ovia.
Yeah, okay, cool. One more thing before before Venkatesh starts. Right. So this. Okay. So this is the diagram we saw before. We saw that Solidity contracts can be created in many tools. Most popular is Remix and Hardhat. After creating this Solidity, you have to deploy it onto some blockchain network. Okay, so this is how we saw this also before. After you create a Solidity smart contract, you deploy it onto the blockchain network, and then you can interact with that deployed contract using several other means. You can have a DApp which runs on Node, which can also be a backend server. You can also directly interact it with a front-end React app or directly via MetaMask. So you deploy it on one of the nodes, and that node will eventually add it to the blockchain via the contract deployment transaction that we spoke about, right? So to create this smart contract, we have several ways. So we've been seeing Remix so far. We've seen Remix via Remix accounts in the Remix VM, which is a single node blockchain. We've also seen it deployed on Sepolia through MetaMask. So now in Venkatesh's session, you'll be seeing how Solidity contracts can be created via hard hat and then deployed. Right. So this is just a small intro I wanted to give. Venkatesh, I'll stop sharing now. So please start your session.
Yeah, okay, thank you. Just give me a moment. Are you able to see my screen?
Not yet. Yeah, I can see. We can see the screen now.
Yeah, thank you. Thank you, and I welcome you all to the practical session of Solidity, where I will code a ballot contract, which is like a normal voting process, wherein you have the list of candidates and a list of registered voters, and you could vote to your favorite candidate. And at the end of the election, we can have the, we can come to know who is the winning candidate as well. Yeah, all along, Ovia was explaining the examples through the Remix IDE, which is an online IDE to write the smart contracts to test it on the local blockchain. And this is an online IDE. And if you wanted to write your smart contracts through VS Code, which is an IDE environment, you can use the hard hat. And another good feature about the hard hat is you can have the scripts written in JavaScript to deploy the contracts as well. I mean, you can write a script with a single script. You can deploy your smart contracts to many networks. You can deploy it to the Corelay testnet. Either you can deploy it in the Sepolia blockchain network, or you can directly deploy it in the mainnet as well. So if you, the hard hat also is very useful for the people who are coming from the JavaScript and a TypeScript background, because you are going to write the test case unit test to test your smart contract in the JavaScript or TypeScript, and also the deployment script as well. You can write it in the JavaScript. So this hard hat tool to write the smart contract comes in handy for, especially for the people who are coming from the JavaScript background. And just like another tool, which is Truffle and Ganache, which I believe we have spoken, hard hat also spins up a local blockchain node for you, providing the 10 dummy accounts and dummy ether to test your smart contracts. And you can deploy your smart contract on the local node, which was spun by the hard hat. So that is another essential feature. So I believe this gives you a general overview of what hard hat is, and for work to work with hard hat, one has to have the Node.js installed on your machine. Node.js version greater than 17. It has to be installed on your machine. Yeah. After that, you can spin up the hard hat. Let me do the same. Let me go to my terminal. Yes, I'm at desktop. I'm going to I'm creating a directory on my desktop. And I'm change and opening it in the VS Code. Once you are in the VS Code, open your terminal. As I said, hard hat is tool is mainly focused uh, with JavaScript in mind. So we also need to install our packages through npm. So the general thing that we do for with any JavaScript product is npm init. We need to do the npm init and y, which will create the package.json for us. And after that, you can install the hard hat npm install uh, so, save -dev hard hat. Yeah, this will install the hard hat packages which we need to work.
Venkatesh, could you also share these commands on the chat box so people can follow
Yeah,
along?
yeah, sure. The first thing that you need to do is create a directory and open your this thing VS Code from your directory. And as the first command, you need to run the npm.init y, which will create the package.json where we are going to have our all dependencies listed there. If you are coming from the JavaScript background, I believe this is fairly straightforward. And after that, you need to run the you need to install the hard hat package, which will install the hard hat. Once the hard hat package gets installed, you need to run the hard hat which will spin up the local blockchain for us. It will ask you, it will give you the options, so whether you wanted to create JavaScript project or a TypeScript project or an empty hard hat config.js or quit. So I'm going to select the JavaScript project, and it will ask you what is the root. I will believe I go with all the uh, default options. What it is? Just 3 errors. Let me check my Node.js installation. Because you need to have the latest version of the Node.js. Let me go to the hard hat documentation site. Installation, setting up a project. Let me check.
Venkatesh, it looks like it worked for some of the others. If you have an existing project, you can proceed with that.
Yeah, just give me a moment. Yeah. It is giving me, and I'm not using the supported version. I think I got it, but it's throwing errors over here. But these are the files actually that you get when you run the JavaScript, I mean npx hard hat. These are the files that you will get. One is the important one is the hardhat .config.js, which will help us to list out what are the things like exports that we are needed. One is which the first, I mean the default, the export that is comes with the hard hat installation is the version of the Solidity compiler that we are going to use when we compile our smart contract. And we can list out other things like what are the, which is the, I mean which network we wanted to use to deploy our smart contracts. So when we come to deployment, I believe we can use that. I will explain there. And it will also spin up it will create a folder called as a contract, and it will create a dummy contract called as a log.sol. Uh, uh, so this is a default contract. It will create it. What I do is I will delete this one, and I will rename it as Barrett. I mean, I wanted to write the smart contract, Ballast smart contract, which is basically an voting smart contract, uh, where we have the list of candidates and list of registered voters, and any registered voter is allowed to vote. And all the, I mean, people who are trying to vote, who are not registered, uh, the transaction gets cancelled if unregistered voter tries to vote. Now, the first thing that needs to be written as a first line of any Solidity smart contract is the license thing, uh, because all the smart contracts, Solidity smart contracts, are open sourced. So we need to declare that this is an open source smart contract which can be used by anyone. So we need to mention the version, general public programming license version 3.0. So this has to be written as a comment, but not as not as a statement. After that, we need to write a first line of our any small Solidity smart contract starts with a keyword called as a pragma, which is basically a, to mention which Solidity compiler we are using. So what I do is
Sorry to interrupt.
I would say greater than 0.8.0.
Venkatesh,
So
can you hear me?
yeah, I can hear you.
Yeah, sorry to interrupt you. So is
Yeah.
there any extension that we should add to VS Code to make it recognize .sol files?
Yes, we need, I mean, we can go to the extensions and we can install the hard hat plugin that would we
So make sure you
yeah,
install this hard hat plugin. This
yes, or the Solidity one.
yeah, it's just so that your VS Code is able to recognize.
Yeah, this one
Solidity.
from the Nomic Foundation. If you go and install this particular extension, Solidity from the Nomic Foundation, which is nothing but a hard hat spun up one, that will recognize your Solidity smart contract files and gives you beautiful, colorful annotations. I believe I can continue, right?
Yeah, please do.
Yeah. The pragma is a keyword in Solidity to mention which compiler version the contract uses to compile your smart contract. After that, you need to mention the contract is a keyword which tells you that this is a contract, Solidity smart contract, followed by the name of the contract. Uh, for me, it is a buyer contract, and the first we have any object oriented programming will have a constructor which called once during the deployment process. So we need to have the constructor written as part of the contract code, and the first variable that I'm going to use is an address which is a 20 byte 20 byte hexadecimal as to store the address of the owner deployed owner who deployed this smart contract. I named this address variable as owner to store the the address which deploys this contract. Now, what I do in constructor is, as I said, the constructor will be called during the deployment, and what I do is I'll store the address of the person who deployed this contract, and the message.sender is a global variable which will be which gives you who either call the smart function in your smart contract, or the during the deployment who is deploying the smart contracts. So I wanted to give some privileges. I do not want my smart contract functions to be called or accessed by everyone from the public domain. So I wanted to have the restrictions placed. I wanted to have these certain functions in the smart contract to be called by owner of this contract. That's the reason why this variable is mentioned appropriately to saying it as an owner. That is one thing. Apart from now, all the variables that are declared outside the functions are the state variables, which has the power to alter the blockchain, and all these variables are stored in a storage location, and it will cost a lot of gas. So we need to carefully choose which variables you are going to use, which type of variables you are going to use. So what address public owner is the first variable, state variable that I declared. Now now next variable is I'm choosing the map variable, where I wanted to map between the candidate name and the votes he has got from the voting process. I believe you already familiar with the mapping, which is a key value pair data structure. which is synonymous like a dictionaries in Python and hash maps in JavaScript. So people coming from the JavaScript, it will be called as a hash map. People coming from the Python, you're calling it as a dictionaries, a key value store basically. So my first mapping variable, I call it as oats, which will map the candidate's name to the number of votes he has got. So this will keep track the votes a particular candidate has received. My another mapping variable, I call it as which will map to an address to pool. I call it as voted. So I wanted the voter to vote only once. Yeah, so I need to uh, keep track of the address of the voter to see whether he is already voter or not. So I will use the boolean flag to turn on and off as per the voting uh, thing. My other variable is another mapping I'm using to map the address to, again this time bool, and I do not want any person, just random person, to come and vote. Uh, I will allow only a registered voter to vote. So I will see in the voting function whether this particular address is a registered voter or not. If it is a registered voter, then only I will allow him to vote. Otherwise, the call to the function simply fails. Now, the other state variable that I am going to use is obviously a string array, and this will stores the name of the candidates. And another variable that I'm going to use is max votes, which will keep the maximum number of votes that received or to a voting person. And another variable that I'm going to use, another string, which will give you the current leading candidate name. If you wanted to query in the middle of the transaction who's leading, so you can do that through this current leading candidate variable. And another one that I'm going to use is a boolean variable, where I will use it to start and stop the election as the owner of this contract. And as a default, I will set it to false. So this completes my variable declaration. Now I'll code the first function. In Solidity, all the functions names starts with a function keyword followed by the function name. I call it as add candidate, and as I said, the candidate will have the candidate array. So it will be a string. It will be stored in a call data. Candidate name. This again an external function. I believe you already know the visibility, different visibilities a function can have: external, public, internal, and view, and pure functions. So difference between the I can code it as an external function and a public function. Public function is accessible to the contract as well as from the external to this contract, but external functions are only accessible from the outside of the contract, but not inside the contract. I do not want to have the I do not have an intention to call this function within the contract, so I'm using the external, which is saves some gas if we declare our function as with external view rather than the public view. And what I do is I need to declare a modifier. I believe you already learned about the modifiers. Modifier in Solidity is a special function where you wanted to run a piece of code, which is generally to validate some inputs. And this particular function can be reused in all the functions. I mean, basically, you do not have to write the code repeatedly. We can place it in a modifier, and we can use the call to this modifier, which will run the code. So modifier function is starts with a keyword modifier followed by your name of the modifier. My modifier name is only owner, and my modifier, what it does is it checks, and it checks for any input checks. So we use the require keyword. What it does is it checks whether the owner is equals to message.sender. I mean, the one it checks whether this particular function is called by the person who deployed this contract or someone else uh, outside of the contract. So we do not wanted to give this access because I wanted the owner of this contract to have the power to add the candidates, but not the external, I mean, to the general public, which will be misused because you can add random persons to that. So require will take one argument which will return a boolean result, either true or which will result in true or false. Based up, if it returns false, then we can throw the error message, not a owner. And after that, we wanted to continue our piece of code. So this is the continuation. So when the modifier hits this line piece of code, it will come to the inside the function, and it gets it executes the function. Now what I do is I will need to have another required statements. I need to say underscore candidate dot. We do not have the length function directly on the string data type, so we need to convert the string data type that is coming into your bytes to have the length. And what we are doing now here is we are checking whether the candidate name that gets passed is not of the zero length. I mean, you can pass a zero string, I mean empty string to this function. So we do not want to a nameless candidate to stand in the voting. So this required statement will checks that it prohibits any candidate name with an empty string. The error string that gets passed when you pass the empty string is empty string passed. This will validate the input. This line is an input validation, we call it as generally. And after the input validation is passed, we just push the candidate name into the candidate array that we just declared in line 11. This is a line 11, which we declared the string dynamic string array. So we are pushing the candidate name into the candidate array. So this completes our add candidate. Now the second function that I wanted to write is add voter. We need to add the voter, and we need to add the candidate as well. Our voter will be identified by his address, because we need to know which address has voted. Again, I will have this function called by the owner of the contract, but not anyone. So we need to again do the input validation. I mean, if we have the argument, I mean, any argument or parameters passed to the function, it is advisable to do the input validation thoroughly, then only proceed with a logic, writing logic for your function. So the input that is passed to this function is an address. So we need to see whether this is not an zero address. If it results in address 0, basically address 0 is an invalid address in Solidity, I mean in Ethereum blockchain world. So if a 0 address gets passed, we need to just return or cancel the transaction. So 0 address passed, we can give the error message as and if it is not a 0 address but any valid address, then what we can do is we need to initialize our mapping variables. I mean, I'm storing the address of the voter in a mapping and initializing it to false because he has just registered. I mean, we are just adding a voter and he has not voted it. So that is a voted variable to false, and this particular address is now registered. So this is set to true. So this completes our add voter function. Now, next function that I wanted to write is vote. And this function will take the string, I mean, the name of the name of the candidate that particular person wants to vote. And this is an external function. I mean, that means all the registered voters gets, I mean, when they call it, they can able to call it. It is not restricted by only owner modifier, because if I do that again, this cannot be called by even the registered voter as well, because registered voter is not an owner of this smart contract. So I'm not mentioning the only owner modifier. It is an external function. So any address can call this function, but only registered voters can able to proceed with the logic of this function. So so we need to do the input validation first. The first input validation is again we are passing the candidate name. So we need to check whether the candidate name is not the empty string. If not, candidate name is empty. This completes our first validation, which is checking the name of the candidate is not an empty string. Now the next required statement is we need to see whether the election has started. If it is election is started, then there is no point. I mean, we need to see whether the election is started or stopped. If it is not started, you are not allowed to vote. Only if the election is started, then you are allowed to vote. Not started. And another the next input requirement valid input validation that we have to do is we have to see whether the address or the person who is calling this vote function is the registered or not. So we can get the address of the address of the person who is calling this function through message.sender. If the registered voter is true, then only you proceed it. If not a registered voter, so you're not allowed to proceed to vote. I believe you're getting some clarity. And another required statement that we need as part of the input validation is we need to check whether this particular person has already voted or not. If he has voted, then there's no point again allowing him to vote. So after finishing all the input validation, what I can do is I need to access this votes mapping with the candidate name, and I need to increase his vote count to 1. So we declared our first mapping, name of the candidate and number of votes he has got. So this is this will increases the number of votes a particular candidate received to 1. And what we can do is we need to see we need to store the max vote count and also the name of the current leading candidate. So what we can do is, if votes of the candidate name underscore candidate name is greater than max votes. So in this case, what I do is I will store the number of votes a particular candidate has received in max votes variable, and also the current leading candidate name. So whenever during the election time, if you wanted to know who is leading, you just query this particular storage variable, which will give you the name of the leading candidate, as well as if you wanted to know what are the maximum votes that a particular candidate has received, then you can very well get it with that. Once you set those storage variables, state variables to the appropriate values. What is this? Yeah. I say vote. I need to set the voted to once you are voted, we need to say voted to true. Yes, he has already voted. So whenever next time when the message this particular address wants to vote, it will result in a revert of the transaction and it gets failed. You're allowed to just basically call once. Now some functions to start election, because we need to set the variables and this gets called only by the owner. This will say, this is needed because only when election is get started, you need to allow to vote, and once the election is finished, stop election. Owner can stop the election. This particular function is not taking any input parameters because we are not doing anything. We're just setting the state variable to true or false here. So it's not taking anything. And some getter functions after this, like get owner, get winner. So if you call get winner an external function, a view function, and this particular function returns the name of the winning candidate. So what it is basically we need an input validation. Again, here some I mean, you cannot just call the get winner to know the winning candidate when the election is happening. That means election is started. You can only call this when it is election started is false. Election going on, so you cannot call this during but and if election has stopped, just return the current leading candidate name or who is the winner. Or we are storing that during the vote function, the reading. The last function that I call it as restart. I mean, once the election is finished, we can just set the storage variables to default values, which will allow us to again run this smart contract for another voting process. So this we need to which I mean, this can only be called when the election started is false. I mean, what now election has stopped, so you are now free to do election is in progress. So you cannot just allow to call in the middle of the election to restart the election. And after that, you need to set some of the storage variables or array values to null. So I'll use the for loop here. Candidates dot length my array I plus plus. Just give me a moment. I hope you guys are following. To remove the array elements, we use the delete keyword. Oops. Name of candidate of I. This will keep looping through the candidates array, and it will delete all the candidates from the candidates array so that I can add the new candidates for the new voting process. So that is what it does. Because we do not want it to have the same candidate contesting for the next election. So every election will have the new candidates. So we need to clear the candidates array. So we are doing that through a delete keyword and looping through the array. And we need to delete some of the clear the variables as well. Then delete candidates. We already did it. The next thing is max votes. We need to set it to 0 because in the next election we are going to stay at 0, and the election started to false. Again, the current winning candidate is an empty string, so we are not storing the previous owner name here. So that finishes the ballot contract or the voting contract, however you call it is. So basically, first I declared the state variables to store the blockchain. I mean, to store the information on the blockchain, and I have the first function which is a constructor to store the owner of this contract who deployed it. I have the one modifier which is called as only owner, which I will be using on certain functions to restrict and can add candidates is used to add the candidates to the candidates array, and add voter is used to add the address to the registered voter mapping, and vote function is used to vote
Venkatesh, there is a
the
typo.
candidates. Yeah.
There's a typo in the modifier owner spelling.
Only on.
Modifier only owner spelling is incorrect. We used the
Yeah. Yeah, thank you. Yeah, this completes the ballet contract. The other thing that I wanted to speak out is how you write the comments as well, because I did not write the comments, but comments as well very necessary. We have different keywords to use
There's
the.
a question, Venkatesh, there's a question from Diana. She says she's missed the last part. Diana, can you elaborate? Let me just unmute you, Diana.
Yep.
Hi. Yeah, I just couldn't follow along on the last part.
Which one? The restart election function?
Just the from 74 to 76.
74 to 76. These are the lines?
Yeah, I already got it. Thank you.
Yeah, as I said, this is the restart election function. This gets called after the election has finished. And when this function gets reused to have the new election get started. So in this for loop, what I'm doing is I'm trying to clear out all the previous candidates who already contested. So that how I did it was I cleared the this candidates array, because this candidates array was used to store the candidate's name. So for the next election, I'm going to have the new candidate. So I deleted all the old candidates. And these are the state variables again gets used in the next election. So this was the max vote was used in the previous election to store the maximum votes a winning candidate got. So this what I'm doing is I'm resetting it. Basically, these three lines are used to reset to its default values. Max votes is default value will be 0. Election started is generally, unless you start the election, its default state will be a false. And the leading candidates, unless the election is started, you do not have the winning candidate name. So that's the reason why I am setting it as an empty string. I hope you got it. Once you have written the contract,
There
I
is a
believe,
question.
yeah.
Question from Makai. The question is, if you include comments in the Solidity file, will it cost more gas when it's deployed? Or
No. I mean, comments are not part of the I mean, it's not get stored on the blockchain. I mean, you only get to run the gas cost you to run your transaction, either transaction in the sense to run your function. So and to store the variables on the state variables on the blockchain. So the gas gets used only for the storage, to store the state variables on the blockchain, and to run the your functional logic. Your functional logic, when you compile it, it compiles to a bytecode. This bytecode gets executed on the Ethereum virtual machine to, what we call it as a computation. So to do the computation, it will cost you gas. So there are only two things that gets the gas cost. One is for the storage, and another one is computation. So the comments only serve for the documentation purpose.
Does that answer your question? Okay, great.
Yeah.
Please
yeah. If I believe if my hard hat is properly installed, if I run this npx hardhat.compile, this should compile my contract. So it's not allowing unexpected error for me. Cannot find the nomic finder toolbox. Okay, I believe this. I got it. Because I mean, when you I need to do npm I installation. I need to install this one. Control X. Just give me a moment. This Nomic Foundation hard hat toolbox, we need to get installed. Again, it's failed. Could not resolve dependency. If you run the if you have successfully installed the hard hat in your machines, if you run the npx hard hat compile, that will compile the smart contract, and it will create a artifacts folder over here. Can someone let me know whether you could able to compile your smart contracts so that I can proceed and explain another contract, because already compiled contract, what folders it gets created. Yes. I think I messed up with my setup. So this is another, I mean, this is my other project, other one. So if you have the, I mean, we are writing the contracts in a contract folder. All the contracts name ends with .sol. And if you run the command npx hard hat compile, this will do the compilation. So this will see compiled 13 Solidity files successfully. So I have the different files, and it will spit out the result whether your files are successfully compiled or not. And it also all these yellow things are warnings. You can ignore those warnings, but if you have any errors, it will spit out in a red in color. So you need to go and fix those errors, then again run the npx hard hat compile.
Venkatesh,
Yeah.
could you share the ballot.sol file to the participants?
It's, I mean, it has 4 files interdependent on it.
No, the ballot.sol file that you just wrote.
Oh, you want to, it's the ballot. Okay. Yes, I can do that. Control A, sorry. Control A. You want me to send it to chat?
Yeah, you can send it to the chat.
Too long.
It's too long for the chat. And then maybe
Yeah.
you can send it to me, and then I will forward it. I'll upload it. Awesome. Thank you.
Yeah. Yeah. if you have if you have run the npx hard hat compile, it would spit out that it has compiled the successfully, and it will create a folder called as artifacts here. It creates two folders called as artifacts and cache. So if you go to the artifacts, then inside contract, you will see all those contracts. What it is, build info, what? Yeah, this file. If you go to the, yeah, it will create an artifacts folder, inside it a contract. And if you click the any Solidity file, which it will spit out a JSON file. This particular JSON file have something called as ABI, which I believe it's already been spoken in the course, which stands for an application binary interface. And if you DApp, decentralized application, or a distributed application wants to call or interact with your smart contracts, that can be done through this ABI. What this ABI stores is, it stores your all the contract state variables as well as the contract functions. So it basically stores the a skeleton of it. So from ABI, you get to know what functions does your smart contract supports to be called from the front end or the back end. So if someone from the front end or the back end wants to interact with the deployed contract, they can do through this ABI. So this ABI is very much important, which is it is part of this JSON file, which is an output of the compilation, hard hat compilation. So when you do the hard hat compilation, after compiling the code, it spits out these files, JSON files, which has this ABI, which gets used in your front end, back end code to interact with the smart contracts that gets deployed on the blockchain. So you might have saw the diagram Ovia shown, where you get to see the two arrows from the front end, back end pointing to the blockchain or the node where the smart contract got deployed. So the way the front end, the back end gets or interact with the smart contract is through the ABI, and ABI lists out the functions that supports to be called from the front end, back end, or outside of the blockchain generally, and the state variables that can be queried. And other beautiful, as I said in the beginning of the lecture, this IDE or the hard hat gets used to even deploy the smart contracts. So if you know the Java, a little bit of JavaScript, you can write the a piece of code to get it deployed either onto different networks. So if you want, I wanted to, yeah, in the beginning of the lecture, this hardhat.config.js, which is a configuration file, which will tell you which Solidity compiler that gets used in this particular thing. I am using the 0.8.17 and some settings like optimizer, how optimized my smart contracts should be. So these are the subsettings of the Solidity variable. And I can, in the networks key of this exports, I can mention which network I wanted to deploy. I am listing it. It has a Gorilla. I can list out by specifying the comma. I can mention any number of networks here. And in my deploy script, which is a JavaScript, I can use, with a single command, I can get it deployed in different networks. So this is a simple JavaScript file and async function. I believe you know, if you are coming from the JavaScript function, this is an async code, because we need to wait for the contract to get mined or to contact to respond to your query. So that's the reason why we need to use the async and await functionality here. And we need to install the npm install ethers, which is needed to interact or to deploy the smart contract on the blockchain. So if you are doing it, you can do npx inst I ethers package. This will gets this ethers package gets installed, which is very much needed if you are doing the deployment, because this will give you, I mean, this ethers.get signers will give you a dummy addresses for your signing and to interact with the blockchain. And after that, it will get the get contract factory, which will get the contract. And also it will gets past the signer one. Signer one is the address. In this case, the message.sender, which gets used to deploy the smart contract, followed by the .deploy keyword, which will use it to deploy. So this is done, everything, the deployment is done through JavaScript programming. So this is basically a small program that gets used.
Venkatesh, there is a question.
Yeah.
What is the command to be able to deploy the contract?
Yeah, npx hard hat.
You put it in the chat also.
Yeah, run. Scripts. Deploy JSON. Network. Go like. If everything goes well, yeah, your smart contracts get deployed one after the other. Our time lock smart contract deployed. So I have I logged the some of the values here, because to know what is happening. See, the tokens deployed at this particular address, my contract. So when you run this particular script, you can, yeah, I can give you this particular script, or you can search in the internet. You get the sample script, which you can edit to deploy your smart contract. The thing is to know which scripts to be run and how you can configure your network settings in the hard config. So it's taking a lot of time to deploy. I believe it's very slow now because it's a US morning. So basically it will be very slow, the network. So, as I mentioned, the other thing that I wanted to mention is what type of node provider I'm using. I'm using the Infura because to interact with interact with the blockchain, you need to, you don't interact. I mean, you interacting with the blockchain is nothing but interacting with one of the node. So in this case, Infura is. Hello.
Yeah. So I think you need to share the config.js, deploy.js with them, because they don't have that goalie command already there. So
yeah. I mean, they cannot able to.
We won't be able to deploy it. We will deploy it after this session. We will deploy it via Remix.
Yeah,
and
because if you go to the infura.io, which is basically a dummy node runner for our blockchain. We do not want it to, I mean, it's a node runner, which is like a gateway to access to the blockchain. So if you go and create an account, you can have the free account as well as the paid account. You can very well go to the infura.io and create an account. And if you go into that, you have the access to, you will get the API key as well as the endpoints of a different blockchains. So this Infura is generally a node through which we will get to access the blockchain or the net, our blockchain. So you can have the main net if you wanted to install, deploy your contract on the main net or the test net such as Gorilla and Sepulia. You can select that particular thing, and you need to copy this thing, and you need to come to this deploy script. And before, I mean, in the hard hat config, you mentioned this one. So when you create the Infura account, you'll get the API key exclusive to you to be used to deploy the smart contracts, as well as the if you install the MetaMask, you will get the private key of your this thing, and also the private key token of the your Gorilla networks. So this private key and private token, you get it from your MetaMask wallet, and this Infura API key you will get it from after you create an account in the infura.io. So this is the API key. So we need to select this endpoint, which endpoint we need to we wanted to install on the Gorilla network, not on the mainnet. Mainnet will cost you real dollars, whereas Gorilla network will cost you a fictitious dollars. And where do we get the fictitious ETH is we have something called as the faucets, which will give you the fictitious of the not real ethers. So you go to this Gorilla faucet, and you type your MetaMask wallet address here, and you when you say send me .eth, it will send the 0.02 ETH to your MetaMask wallet. Now that 0.02 ETH is sufficient enough to deploy one smart contract. So these two, I believe, Ovia will, I believe she is yet to show how you interact with injected service providers such as MetaMask. At that time, we will show you how you can get the private key and private key token from the MetaMask, and how you can, I shown you how you can get the Gorilla ETH, which gets used for the deployment, because even for the deployment also you need to pay the fee, some amount of fee to deploy, because it will run some amount of computation to deploy your contract, and you will get the API key from the Infura. If you have all these three, you write this one networks dot colon into Gorilla, and you mention the API URL, and also what are the accounts that can used. There are two accounts, private key and private key token. These are two accounts. I mean, in your case, you can have only just one account, because here this is a different smart contracts where I am using the multiple accounts to deploy that smart contracts. In your case, you can just have one your one MetaMask account private key. So I can give you this. I can give you this sample thing as well.
Venkatesh, you can directly upload the file in the Zoom chat box. I have uploaded the ballot.sol file.
Okay.
You can just upload a file in the chat box.
Okay. So now see, when I ran this npx hard hat run scripts.deploy that, I'm mentioning the path of my deploy scripts to a command called as npx hard hat run. For compilation, we use npx hard hat compile, whereas for the deployment, we use npx hard hat run, followed by the script where we have where we have our deployment script, followed by --network to which we are trying to deploy our smart contract. In this case, I am mentioning it as a Gorilla, so that my smart contracts go and deployed in this network. So once the deployment is successful, you get to see the address where it gets deployed. I mean, you get the address where it got deployed, so that you can interact with your smart contracts and which particular address has deployed it. In the message.sender in this case, this is the address in my case, which is a message.sender. Now, if I go to this particular this transaction address called as copy, I'll copy and I'll go to his Gorilla ether scan. Gorilla. This is the Explorer where we can see the deployed smart contracts. Yeah, 5 minutes ago. Yeah, contract creator, a transaction has created. So this my contract, my smart contract created the contract on the Gorilla network as well as done some transactions. So this is done in 6 minutes ago. So if your deployment scripts is successful, then if you copy the address of the deployed smart contract address, if you go to this gorilla.etherscan.io, and if you search on the search box, you get to come to these particular things. So if I click here, see it's got successfully deployed. It says success. There were 15 communication. Yeah. Any doubts? Anything to be clarified?
Guys, so if you find the interface of Hardhat a little bit complicated, it's fine. You can continue using Gradle for small projects. These are just tools to help you write and manage your Solidity contracts and deploy them into any of the blockchain networks. You can do that with Remix also, which for smaller, when you just have 1 or 2 contracts. If you have a big project, then it makes sense to use Hardhat. Right? So for the, thank you so much, Venkatesh. If there's any questions, please post it and we'll make sure we'll pass it on to Venkatesh so that he can answer it for you. I just want to, before we wrap up this session, Venkatesh, I would like to show them the ballet.sol in the Remix interface also, so they have some familiarity.
Yeah, sure, definitely.
You can stop sharing your screen, I can share and...
yeah, definitely.
Thank you. Awesome. Let me just share my screen. Right. I hope you can see. Right. So this is the ballet.sol file that Venkatesh just wrote for us. I have just copied that file into the Remix. I've just created a new file and pasted the content, right? So if you can see, it is the exact same file and that all of you have written, and it has already compiled. I can just deploy it directly using in the Remix VM. I can deploy it, and you have all the functions that you guys wrote here, and you can directly play with it over here. I can add a candidate, I can start the election, I can vote, and I can also get the results. So as you can see, all the read functions are written in blue, and all the write functions are written in orange. So this is how you can interact with it. And like, so you can use different way to deploy it. So if you want to deploy it on Sepolia, so we are familiar with Sepolia. We already have MetaMask and with Sepolia ETH in via faucets. So I'm calling my injected provider MetaMask. Close this. yeah, so now we have some Sepolia ETH. I was able to log into my MetaMask. So now with via injected provider, if I deploy, wait, let me just reload this. Yep. Okay. Connect to localhost again. Yep. So this is the file that we're looking at. So now I'm just deploying it in injected provider. My Frontier wallet is just taking over. Let me just, I don't know why that is happening.
Press on those 3 dots. Yeah.
What?
See, yeah, connected sites. Yeah.
Right. Right. So let's see if I can deploy them. What is the error? From is not defined. The account is not selected again. Why is I have 2 wallets and it's asking me for this? But I don't have Sepolia ETH over here. Should I just let me just delete my Frontier wallet for now. Okay, I'll just reload my Chrome. Let me just reload this again. Sorry about this, guys. Again, this is another reason why hard hat is better. You don't have to worry about all of this. Okay. Back to my wallet. Deploy injected provider. Yeah. So now it's asking me, so I'm trying to deploy the ballot contract via MetaMask. I've selected injected provider MetaMask, and the MetaMask is connected to Sepolia test network. So now I can see that it is charging me some gas fees for deployment. As we saw that deployment is a type of transaction which requires gas fees. So I'm confirming it, and the contract has gone through. So I'm able to view on Etherscan. So this is the transaction, and this is the contract. It's a contract creation transaction, which has no, yeah. So this is the contract that is created. So this is an account. Contracts are accounts. So we can even see the contract also on Etherscan. So if we verify the contract, we can, actually I haven't shown, Venkatesh, if you're there, I would like you to help me verify this contract.
Yeah.
So
we need to select the exact compiler version which you used.
So I think what compiler did you use?
I think it's 8.0.0 080.
How should I write that? Like
single file, Solidity single file.
And compiler version is 8.0.
Yeah. Select 0.8.0. Come down.
This one?
0.8.0, the last one.
Oh, okay. Right.
Select
And
the
the
license, yeah.
what's MIT?
GPL3 5.
Where is it?
GPL3, yeah.
GP
7. You can select 7. General public license 7.
Seventh one? Okay.
Yeah.
Okay, so continue. If I do this, now I can enter the code of the Solidity contract. Let's just copy the code from here. Copied the code. Just going back to Etherscan. Yeah, I'm just copying the code over here, right? Anything else? I should write the ABI here?
No. We do not pass any constructor arguments, so we don't have to do.
Okay. Not robot, verify and publish. So now what we're doing is, so as Venkatesh mentioned, when you deploy a contract, the Solidity code is
General.
code. What has happened?
Okay, you can select any, I mean, greater than 8.0, select 8.1 or 8.2. Start over. Yeah. Just select more higher version than 8.0. I have written the greater than symbol.
I'm not able to change this. Should I go back? Yeah. Okay, so I'll 8.1 I'll select.
Yeah, continue. Let's see.
Right.
Yeah, again, 8. What are those 8 red color lines? Does it show anything?
So as I was saying, the Solidity code is compiled into bytecode and unable to generate again. We already did this, right? So it doesn't match. Why is that?
It's not the same contract. It's the same.
Yeah, it's the same code, no?
Yeah.
We just published it. Did I copy it wrong or something? This is strange.
Yeah. Okay. You go back. We enabled the optimization. Is it because of the optimization thing?
Optimization is disabled. It's a single file. Unchecked to show. Should we just do some higher version? Is that a problem?
No, I guess you can select. Yeah. See.
So or should we like just write it as a different compiler version?
No, I don't think so.
GPU.
We are saying it.
Okay.
Is it because of the optimization? What is this 8 red color one? Yeah, you can say yes and see.
That
if
is just Grammarly. That is just showing me.
Okay.
That is not a error.
Okay.
Okay. It's not an error. Okay, guys, I'm not sure why this is happening, but the gist is if you verify it like this, then you should be able to, how Remix shows you read and write functions here, right? You can interact with the contract the same way in your Etherscan. It's a good practice to do this because people will trust your contract. They'll be able to read the code also because you're uploading the code and it is just more transparent. So that is the end objective of this, right? So one we were looking at contract creation of another contract. So now that my MetaMask is working, I'll also show you that quickly before we wrap up. We were looking at a car factory creating cars. So let us deploy that quickly. So let us delete all the other contracts we have. So let us deploy the car factory. So the car factory is deployed through my MetaMask, confirm. So now we have a car factory. That is, let us wait for it to create. Yep, it is created, I think. Yep, it's created. So we have a car factory contract over here. So now let us try to create a car. So now I'm going to my car factory. I'm going to create a car, right? I want to create a car for myself. So I'm just copying my MetaMask address here. And now I go to the create function. I'll create a car, passing my address, and I'm creating a Tesla. So if I create, again, it is a transaction. I'm invoking the create function. I'll confirm it. Now, again, the transaction is going through. It has interacted with this contract. So now this contract should have a car, one car added to its array of cars, right? So I'm going to get the car value at 0, which is my car, right? So it should be, I'm the owner. It's the model Tesla, and this is the address of the deployed contract. I'm just going to copy this address. So this should be a new contract that is created for by my car factory. Okay, this contract didn't exist before. So if you can see, I'm just going to paste this address over here. And if you see, yes, this is a contract that was just created. Let me just 055. Yeah, so this is a new contract that is just created. And if you can see that there is no internal transaction that has happened on this contract yet. So, yeah, that's it, guys. This is what I wanted to show you guys. Any doubts on this session? We run a Remix D in our editor. Yes, if you want to connect to localhost. If you want to connect to one of your local file systems, then you need to run Remix D. So if I just, it's running in my background. If I stop it here by Control C, then I will no longer be able to connect to my local host. It won't work. So that's why. Any question? Any other questions? Yeah, so you deployed the contract successfully, but not seeing it in Ethereum. You must go to the Sepolia. If you've used Sepolia, if your MetaMask is connected to Sepolia test network, then you should go to sepolia.etherscan to see it. You will not be able to see it in Etherscan mainnet. Right? Does that solve your problem? Okay. Okay, you are in Sepolia, but you're still not able to see it. You can unmute yourself and
Sepolia, you can
Yes.
also share, like you can also, Makai, you can also share your screen and check.
Okay, I put it in the hash and I'm doing it in Remix.
in Remix, did you copy the correct hash?
So there's a transaction hash that I copied. Is that?
Yeah, you should be able to see the transaction hash also in Sepolia Etherscan.
Okay,
Can
it's not coming through for some reason. Yeah, I'll share my screen if that is okay.
Yeah.
Okay, can you see?
I can see your screen.
Okay.
You go to your Remix.
Yes, sorry, too many screens open. Remix, there we go. Okay, so I'm in here, and this is the contract that I've created.
Right. So did you use MetaMask to deploy this contract?
So I thought we connected MetaMask already and I have it open, but it doesn't do, it
If
doesn't
possible,
consult it.
yeah, can you just deploy this contract again?
Yeah.
And I'll see how you've done it. Yeah, can you go up? Can you scroll on the left?
Yeah,
Can you
she selected local host. Yeah.
just scroll up on the left?
Oh, sorry. Up here?
Yeah, scroll up. Yeah, here you've selected Remix VM. Remix VM is a single node that's only on to choose injected provider.
Okay. That makes sense.
And then deploy.
Okay.
Then your MetaMask transaction will show up. Yeah, just deploy now.
Okay, I deployed it and this is,
No, that you still haven't
oh,
deployed.
that's not the same. Okay.
No, you have to deploy it again. So
This
can you
one.
just open your MetaMask for me?
Yeah. So I deployed it and it's just,
No, you haven't, because it should ask your
oh,
MetaMask
it's not
to sign the
connected.
transaction. Yeah, so
Okay.
it's not connected properly. So so this happens constantly with Remix. You will have to disconnect your MetaMask, refresh the Remix on the browser, and reconnect to the site. So
Oh,
that's the way to do it. So you can just minimize this screen. Can you see in this Remix screen? Can you see this jigsaw puzzle on the top of your Chrome browser? The icon, yeah. Can you click on that? Just pin MetaMask.
okay.
Yeah. So can you see the one here? That means
yes.
it's asking you to sign, but because just click on it. Yeah, so it's actually asking you to sign, but then since you hadn't pinned it, you didn't get a notification.
Oh, okay, good to know.
Go down and
So
confirm.
just,
Yeah.
okay. Oh, so I have to do that periodically.
So now the contract development is going on.
So this is it, what I just.
Right. So now if you go to the other, after this is done, you would see that your money is reduced in the other screen. Yeah, can you?
Oh, yeah. Okay. Okay, perfect. So then it should show up.
Now you can copy this transaction hash on, check it on Sepolia Etherscan.
Okay, gotcha. Perfect. So this is it.
Yeah.
Okay, great. Thank you. And then I can just play with it in here. Awesome.
Yeah.
Okay,
Yeah,
so
please
remember injected provider.
Yeah, you can actually test all of the functionalities in the ballot.sol. You try to add candidates, start an election, just play around with it. Also create your own factories and try to deploy other contracts through another contract. So
okay. Yeah. Today. Okay, great. Thank you.
Awesome. All right. Any other questions? Okay, we've covered quite a bit today. We had an excellent session by Venkatesh, and we developed our own election ballet contract. So I hope you guys learned how to write your own Solidity contracts. So using this example, you will be able to write it for almost anything. And I'd like you to try on your own, like how we wrote a contract for the election use case. You can write a contract that, let's say, for an auction use case. How would you add, start an auction, put items up for bidding, let people bid on that item, and then close the auction and declare the winner of who gets the item. That could be a nice use case that you could try to write your own contract for. So do try. If you do write that contract, feel free to send it to me, and I will have a look at it, and we can talk about how you can write it better, or if what you've done is good. And in the next class, I'll see you again. We'll talk about ARC standards, and then we'll talk about a couple more use cases. Right. Thank you, guys.
Yeah. Thank you. Thank you, Ovia. Thank you, Venkatesh, for the amazing session as well. And in case you have any doubts, you can start your projects. You can share it in Slack, or you can directly share it to Ovia over email. All her social media handles are as well shared in Slack channel, and we'll share Venkatesh's socials as well.